Good morning, students. I welcome you all for today's session. So, in today's session, we'll be starting with the numerical part on thin cylinder. So, I have noted the first problem for you. So, let us start with today's session. A cylindrical drum, 800 mm in diameter and 3 meter long, has a wall thickness of 10 mm. If the drum is subjected to an internal pressure of 2.5 Newton per mm square, calculate the change in diameter, change in length, and change in volume. Take Young's modulus as 200 GPa and Poisson's ratio 1 by m as 0.25. Okay, so this is the problem given to us. So let me start with the solution part. So let me start with the solution part. I need to find out the change in diameter. So if you want to find the change in diameter, you should know the circumferential strain. Secondly, you need to find the change in length. Then you need to know the longitudinal strain. Right. So my first target is to find out the circumferential strain and the longitudinal strain. Right. So circumferential strain is given by circumferential strain is given by. So we know that. So circumferential strain is equal to sigma c divided by E, sigma c divided by E minus sigma L divided by ME, sigma L divided by EME. Right, so we already studied that this is the formula for circumferential strain using generalized Hooke's law. So suppose if I take this as equation number 1, here I need to find out the value of sigma c and sigma L. Value of E and 1 by m is given to me in the problem. Right, so first let me find the value of sigma c. So sigma c is given by PD by 2t, PD by 2t. Right, so this is the formula used to calculate the circumferential stress. So what is the value of P? Value of P is 2.5 Newton per mm square into diameter. Diameter is 800 mm, so 800 divided by 2 into wall thickness is 10 mm, so 10 mm. Right, so let me calculate what will be the circumferential stress. It is 2.5 into 800 divided by 20. Right, so it is giving me the value as 100. So it is 100 Newton per mm square. Similarly, I'll calculate sigma L, which is PD by 40. So value of P is 2.5. D is once again 800 mm in diameter. 4 into T is 10. So if I do this, let me check out what I am getting. 2.5 into 800 divided by 40. So I am getting the value as 50. So it is 50 Newton per mm square. So therefore equation 1 becomes therefore equation 1 becomes so equation 1, epsilon c will be sigma c by E. Sigma c value is 100 divided by value of E, it is in GPa. Everything here thereafter is in Newton per mm square, so I need to put the value of E is in Newton per mm square. So if you convert 200 GPa into Newton per mm square, it will be 2 into 10 raised to 5. Right, so I already told you in the first unit what is the conversion, how you are going to do it, so I am not going to repeat it. I request you people to go back to the videos of first module and just go through the conversion part. Right, so 100 divided by 2 into 10 raised to 5, minus value of sigma L is 50 divided by value of 1 by m is 0.25 and value of E is 2 into 10 raised to 5 into 1 by m is 0.25. So this if I check out, therefore value of epsilon c will be how much? 100 minus 50 into 0.25, 50 into 0.25 divided by, denominator is common, 2 divided by 2 into 10 raised to 5. So I am getting the value as 4.375 into 10 raised to minus 4. 4.375 4.375 into 10 raised to minus 4. Right, so since it is a strain, it will not be having any unit, so I am not writing any unit. So similarly, I need to find out the expression for epsilon L, that is longitudinal strain. So it is given by sigma L divided by E minus sigma C divided by ME. Right, so it is the normal generalized Hooke's law I am using here in this part. So therefore I know all the values now. Epsilon L is equal to value of sigma L is 50 divided by 2 into 10 raised to 5 minus value of sigma C is 100 into 0.25 divided by 2 into 10 raised to 5. Right, now if I just solve this, I'll be getting the value of epsilon L as, so let me check out, it is 50 minus 100 into 0.25, 100 into 0.25. So this should be divided by 2 into 10 raised to 5, 2 into 10 raised to 5. So it is 1.25 into 10 raised to minus 4. 1.25 into 10 raised to minus 4. Okay, so these two values are important for us. So I got the circumferential strain, then I got the longitudinal strain. I'll make use of these two things and I'll find the change in diameter and change in length. Okay, so let me calculate change in diameter. So change in diameter, I'll call it as delta D. I'll take the value as delta D. Right, so it is given by epsilon C into D. Right, because I'll just write it in bracket. Circumferential strain is caused because of change in diameter, so it is delta D divided by D. So I am interested in this delta D. I'll cross multiply these two things and I'll get this expression. So therefore delta D is equal to value of epsilon C is 4.375 into 10 raised to minus 4 into the diameter which is given to me in the problem is 800 mm. 800 mm. So therefore delta D is equal to how much? 4.375 into 10 raised to minus 4 into 800. So it is 0.35. 0.35. 0.35 mm. Similarly, change in length. Change in length. So it is delta L. So it is given by epsilon L into L. Reason longitudinal strain is because of change in length. So this is the formula. If you are interested in delta L, so I need to use this formula. So therefore delta L is equal to value of epsilon L is 1.25 into 10 raised to minus 4, 10 raised to minus 4 into length. Now here you be careful, it is 3 meters long. So when it is 3 meters long, I need to put it in mm. So therefore delta L is equal to, so let me check out what will be the value. So it is 1.25 into 10 raised to minus 4 into 3000. So it is 0.375, 0.375 mm. Right, so we got the change in diameter, we got the change in length. So next let me find the change in volume. In order to find the change in volume, first let me calculate volumetric strain. So we know that epsilon volumetric is epsilon longitudinal plus 2 times epsilon circumferential. Right, so therefore epsilon volumetric is equal to epsilon longitudinal is 1.25 into 10 raised to minus 4 plus 2 into value of epsilon c is 4.375 into 10 raised to minus 4. So therefore epsilon volumetric is equal to, so if I simplify all these things, let me check out what I'll be getting. 2 into 4.375 into 10 raised to minus 4 plus 1.25 into 10 raised to minus 4. So I'm getting the value as 1 into 10 raised to minus 3. 1 into 10 raised to minus 3. Right? So it is 1 into 10 raised to minus 3. So once again, this epsilon volumetric does not have any unit because it is change in volume. Right? Whenever it is change in volume divided by original volume, so strain is unitless. That is the reason it does not have any unit. So now epsilon volumetric is equal to change in volume divided by original volume. So I am interested in change in volume, so therefore change in volume, so sometimes it is also written as delta v divided by v, both are same, right? So therefore dv is equal to epsilon volumetric into the volume of the cylinder. So therefore if you just proceed further and solve for dv, epsilon volumetric is 1 into 10 raised to minus 3 into volume of cylinder. So how you calculate volume of cylinder? It is pi by 4 d square l. Pi by 4 d square, diameter is 800, l is 3000. So therefore change in volume is given by, so it is 10 raised to minus 3 into pi into 800 square into 3000 divided by 4. So change in volume is 1.507 into 10 raised to 6, 1.5079 into 10 raised to 6, and unit will be mm cube. Right, so this is the change in volume. Right, so that's it for today's session. Have a great day. Take care. Bye bye.